this lesson is interval notation. Here's a question for you. It says, list all of the real numbers from 1 to 100. Okay, so you could try to do that. I could say, all right, the number 1. Then I could do the number 2, and the number 3, and the number 4, and the number 5, and the number 6. But the question is this really all of the real numbers? Probably not, because between the numbers 1 and 2, there are infinite numbers. There's number 1/10, there's the number 1/2, there's the number 2/3. It would be really, really hard for you to try and list every single real number between 1 and 100. It would just take you probably the rest of your life. So this is why we have what's called interval notation. Interval notation is a way that we can summarize a set of numbers, usually a very large set of numbers, very quickly using mathematical symbols. So here's what it would look like. This is interval notation for all of the real numbers from 1 to 100. When you first look at it, you're probably thinking, I don't really know what that means. Well, if I were to read this, it is read as x such that. Okay, the phrase such that is represented with that vertical bar. X is any real number from 1 to 100. And we summarize the number from 1 to 100 using this compound inequality, or what we call this interval. It's saying that the value of x that we're looking at could be anything from 1 to 100. It could be any integer between 1 and 100. It could be any fraction between 1 and 100. It could be the number pi. There are many numbers from 1 to 100, but we were able to summarize all of those numbers very quickly and efficiently. Another way that we can represent a number set is using a number line and graphing all of the numbers that we're discussing. Using a number line is pretty simple. If we want the numbers from 1 to 100, I'm going to put in numerical order 1 to 100, and anyone reading this number line would assume that this represents, even though I didn't write every number between 1 and 100, they're assumed to be there. So when I graph, I'm going to put a closed circle at 1 and a closed circle at 100. Then I'm going to take my pencil and I'm going to shade the number line from 1 to 100. So what this means is that anywhere my pencil touches, that represents a real number. Let's try it again. Sometimes the more you practice these, the better they make sense. So here's the first question. List all of the natural numbers less than 100. Here's how we can do it in interval notation. Start off with a curly bracket. And we'll write x such that. And you always start off with that with interval notation. The open curly bracket, x, and such that. So once you get in the habit of it, it kind of becomes second nature. Now, the important thing is natural numbers less than 100. So I want to write an interval. X is less, I'm sorry, did I say 100? I meant 10. X is less than 10. I think I was stuck using 100 because of the previous example. So let's start over. Open a curly bracket, x such that x is less than 10. Now, could I close this bracket? Would that represent all of the natural numbers less than 10? Or is that specific enough? Well, no, actually it's not specific enough, because if I were to write just this interval notation, x is less than 10, that would mean all of the real numbers less than 10, like 9.5 or pi or negative 1,000. 0 is a number that's less than 10, but not a natural number. So we need to be more specific. So I'm going to erase this bracket, and I'm going to put a comma. And this is where I'm going to put a little extra statement in here. I want to say that x is an element, remember it looks like that curved C, of the natural numbers. And natural numbers are represented with an N and a double bar like that. This one's kind of ugly. And then I'll close my bracket. So this now represents all of the natural numbers that are less than 10. Okay, let's try putting it on a number line. Here's my number line, and I want natural numbers less than 10, so I'll put 10 over to the right because that'll be a large number. And then let's think, natural numbers less than 10. Remember, the set of natural numbers is all of the positive integers, the numbers that we count with. 1, 2, 3, 4, and so on. So really, we're not talking about too many numbers. The natural numbers less than 10 would include the number 9, 8, 7, 6, 5, 4, 3, 2, 1, not the number 0. So I'm going to put a closed circle on 9, a closed circle on 8, 7, 6, 5, 4, 3, 2, 1. Notice how I'm not using a solid line like I did with the other example. If I used a solid line and colored in the numbers between 8 and 9, those would all be real numbers between 8 and 9 that are less than 10. However, they would not be natural numbers. That's why I'm using only dots on the natural numbers. So this graph is, or this number line is acceptable. Some people might say, well, the inequality said that x was less than 10. So some people might put an open circle at 10 to stay true to the interval. It's really up to you. It's your choice. I wouldn't be too worried if you put an open circle at 10 or not, but the option's there if you'd like to do it. Okay, so let's try some examples. I'd like for you to press pause and list or describe all of the numbers in the following number sets. Once you think you have listed or described the numbers in the number sets, press play and check your work. Okay, the first interval notation. This is read that x such that -2 is less than or equal to x, which is less than 4. Okay, that's a lot of real numbers. So I couldn't really list them, but I can describe them. I would say that this represents all real numbers greater than or equal to -2 and less than 4. Notice I didn't put or equal to because the symbol doesn't have the bar underneath it. It just says less than 4. But for the other part of the interval, -2 less than or equal to x, so I needed to make sure that -2 is included in that set. All right, the next one, x such that -3 is less than or equal to x, and x is less than or equal to 5, and x is an element of the natural number set. So natural numbers, if you remember, are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Remember, all of the positive integers. So -3 is not a natural number. Actually, within this number set, I can only start with 1, 2, 3, 4, and 5. That's it. The third example reads, x such that x is greater than 1 and x is an element of integers. So this means all of the integers greater than 1. If you wanted to try and list those, you can maybe do like, oops, could I write 1? No, that's incorrect because 1 is equal, but we want greater than 1. So the first integer greater than 1 would be 2, 3, 4, 5, and so on. This is an infinite set because it would continue to infinity. All right, I hope you did a good job. Let's move on to graphing using interval notation. So example 2 says, sketch the number sets on a number line. Okay, take a minute, press pause, and see if you can graph these numbers on a number line. Okay, so we have all of the real numbers greater than or equal to -2 and less than 4. So what I'm going to do is I'm going to show on my number line -2 and 4. I'm going to put a closed circle on -2 because -2 is a part of the number set. And then I'm going to put an open circle at 4 because the number 4 is not included in the number set. I can include numbers very close to 4, like 3.9 or 3.99, but 4 is not included, so we put an open circle there. And then I'm going to take my pencil and shade all along the number line between -2 and 4. All right, next example, x such that -3 is less than or equal to x, and x is less than or equal to 5, where x is a member of the natural number set. So we said that before. Like if we wanted to include -3, -2, -1, 0, all the way up to 5, we wouldn't put any closed circles on -3, -2, -1, or 0, but 1 fits in that category. So does 2 and 3 and 4 and 5. I don't want to go beyond 5. Last example, we would read that interval notation as x such that x is greater than 1, where x is an element of the integer set. So all integers greater than 1. So I'll start writing in here. Maybe I could put a 0, 1. The rest of these would be considered integers. And I'm going to put a closed circle starting at 2, because remember 2 is the first integer that is greater than 1. I'll put a closed one at 3, 4, 5, 6, 7, 8, and it's an infinite set. To represent that a pattern continues infinitely, I like to darken in the arrowhead to represent that it continues in that pattern. Some people choose to draw a little arrow above to represent that it continues in that pattern. That's fine. It's personal preference. I like to darken in the arrowhead. Okay, last example. This time we're going to be given the graph, and you are going to write the number set in interval notation. So let me fill some in for you. How about we do something like this? How about a problem like this? And then one more, how about so press pause. See if you can write the number sets graphed on the number line in interval notation. And when you're ready to check your work, press play and check. Okay, so the first one, I have a solid line. So that's going to represent all real numbers. The solid line continues to the left, so we're getting fewer and fewer values. So we're looking at less than 5. And then since it's an open circle, that means that the number 5 is not included in the number set, but all of the real numbers less than 5 are. So to write it into interval notation, open a bracket, write your x in your little vertical line. So we have x such that, and remember we said that these are real numbers that are less than 5, so use the inequality. X is less than 5. And then since these were all real numbers, I don't need to specify anything, so I'm just going to close my bracket. For B, we have -2, -1, 0, 1, 2, and 3. So these are all solid circles on top of integers. And then these integers range from -2 to 3. So I'm going to need a compound inequality to show that I have a lowest value and a highest value. So open up a bracket, x such that, and then I'm going to start with my lowest possible value, -2, which is less than or equal to x, and then x is less than or equal to the highest value, which was 3. And then since all of these numbers were integers, I'm going to fill in x is an element of the integer set. Okay, and then for part C, we have a solid line again. This time it's drawn to the right, so this means real numbers greater than something. And then a solid circle at 4, so it's greater than or equal to 4. So I need to make sure I include that in my interval notation. So I'll start it. Open a bracket, x such that x is greater than or equal to 4. And then since I'm saying all real numbers that are greater than or equal to 4, I'll just go ahead and close my bracket. Okay, this is interval notation. This is going to come in handy as we work further into functions, because we're going to use interval notation to express number sets that we call domain and range.